Okay, so this video is going to go through transformations and functions with some funky notation. It's a good pun. So basically we want to know what this stuff does. Okay, if you have a negative outside f of x, what happens? If you have a 4 outside f of x, what happens? If you have a 3 inside the brackets, what happens? If you have a negative 3 inside the brackets, what happens? And we're just going to focus on dilations and reflections. And ultimately, I think these ones are relatively easy to see. So if you have y equals minus f of x, right, you might have your normal original function as root x, and y equals minus f of x. This just makes all the y values negative. Negative 1 times the original makes the y values negative. So you get that. And that's a reflection in the x axis. Okay, the x axis is a mirror. If you have that point there, it's the same distance away as that point there. Okay, so it's reflected in the x axis. Okay, the next one says dilation by a factor of 4 from the x axis. So again, I think it's sort of easy to see. If y equals f of x is root x, right? If you then do 4 times f of x, what you're doing is you're taking every single xy coordinate and multiplying the y value by 4. So for example, 1, 1 would become 1, 4. Alright, let's just check. If y equals 4 root x, chuck in 1 for x, you get y equals 4. Alright, so every single y value has been multiplied by 4, and it's going away from the x-axis, so that's the language there. Dilation by a factor of 4 from the x-axis. Now these ones here you can just memorize, and I probably recommend that you do memorize them. If there's a 3 inside the brackets, it turns out to be a dilation by a factor of third from the y-axis. And then if it's a negative inside the brackets, it's a reflection in the y-axis. But I'm going to show you the method, the formal method as well, if you can't remember that. So basically what happens is you have your function which is root x, say, and that has a bunch of xy coordinates on it because lines are made up of points. And you take that function and you transform it by making everything in the brackets 3x instead of x. So it becomes 3x, whatever that looks like. And we call this guy the image. Alright, so what's happening is you're taking the original function, you're transforming it to be the image. We call it y dash and x dash. Alright, 3. And the method is to equate the things that look similar. So we have something inside the square root, something inside the square root. So we just equate x equals 3x dash and y equals y dash. And ultimately what we're wanting to find is how the original set of coordinates gets transformed to x dash, y dash, the image coordinates, whatever they are. And so I've written x in terms of x dash, I just need to solve for x dash. So solving, you get x on 3 and y dash stays the same. Alright, so every single xy coordinate, what's happened is it's been mapped to x on 3 and y. So every single x coordinate has been multiplied by a factor of a third. And what does that look like? Well, you have some xy coordinate here. If you multiply that by a third, it's going closer to the y-axis. So x on 3 and y. It's going like that. And that's a dilation by a factor of a third from the y-axis. Alright? And then if you had a negative in there, what's going to happen is the following. You do the same process, and the x coordinate's been multiplied by -1, so you get a flip in the y-axis, which is a reflection in the y-axis. Okay, so you can go ahead and memorize those transformations if you wish. Let's do a quick example. If f of x is 3x, okay, and then you're asked to sketch negative f of 2x, well, you can just make the substitution and see what it is, but you can do it step by step as well. Okay, so what does 3x look like? It looks something like this. What would the negative do? It's making every single y value negative, which means that this one goes down to here, 1 minus 3. I'm going to try and do it as best I can as a reflection in the x. Maybe more like that. Alright. And then what's the 2 going to do? Well, it's multiplying every... We should know it's a dilation by a factor of a half from the y. So that point there, 1 minus 3, now goes to a half minus 3. So now it looks like this. Okay. And let's just check. If you sub in the following, you're going to get the result or the image to be minus, sub in 2x into there, minus 6x. Okay, the image is that. If you sub in x is a half, do you get back y is minus 3. You do. So you get back this line, which is y equals minus 6x after you've done the transformation. Okay, that's it.